I now turn to the subject I meant to introduce, which was the experiments on the small scale to see whether things really attract each other. And I hope now that the next slide does indicate, this is the second try, yeah, Cavendish's experiment. The idea was to hang by a very, very fine quartz fiber a rod with two balls, and then put two large lead balls in the positions indicated here next to it on the side. Then, because of the attraction of the balls, there would be a slight twist to the fiber. It had to be done so delicately because the gravitational force between ordinary things is very, very tiny indeed. And there it was. And it was possible then to measure the force between these two balls. Cavendish called his experiment weighing the Earth. We're pedantic and careful today. We wouldn't let our students say that. We would have to say they're measuring the mass of the Earth. You know? But the reason he said that is the following. By a direct experiment, he was able to measure the force and the two masses and the distance and thus determine the gravitational constant. You say, yes, but we have the same situation on the Earth. We know what the pull is, and we know what the mass of the object pulled is, and we know how far away we are, but we don't know either the mass of the Earth or the constant, but only the combination. So by measuring the constant and knowing the facts about the pull of the Earth, the mass of the Earth could be determined. So indirectly, this experiment was the first determination of how heavy or how massive is the ball on which we stand. It's a kind of an amazing achievement to find that out, and I think that's why Cavendish named his experiment that way instead of determining the constant in the gravitational equation. Weighing the Earth. He incidentally was weighing the sun and everything else at the same time, because the pull of the sun is known in the same manner.